Solve by addition method. Oh goody, this first problem is set up nicely for addition method. Why do I say that? Because look at those x's. I don't even have to do anything to those equations to get those x's to cancel out. They already have the same coefficient, opposite signs. So when I add them together, 4x minus 4x is nothing, gone. That's what I want to happen. 8y plus 2y, 10y. 20 and negative 30 is negative 10. I can just solve for the y. This problem is set up perfectly for addition method. I already have the y. Now I just need to find the x. So take one of your original equations. Doesn't matter which one. We now know that y is negative 1. Eight times negative 1 is negative 8. Now I'll solve for x. So my answer is 7 is the x-coordinate, negative 1 is the y-coordinate. Again, to check those in a calculator, just type in 4 times 7 plus 8 times negative 1 and see if it equals 20. Type in negative 4 times 7 plus 2 times negative 1 and see if it equals negative 30. That's how to check your answer on these. Next problem. Okay, I need to choose, am I going to eliminate the x's or eliminate the y's? I don't think it matters. Sometimes there's an easier choice, but I think I'll just choose to eliminate the x's. I need to get it so the x's have the same coefficient, opposite signs. They already have opposite signs, so I don't have to mess with the signs at all. If I multiply by 3 and 2, I'll get 6x and negative 6x. So now just distribute. One of the most common mistakes I'll see is people will put a 1 here. They'll forget to multiply the 3 times the 1. Be careful for that. Now we've got our equation set up. With the x's, we have the same coefficient, opposite signs. So now we're ready to add our equations together. 6x and negative 6x is gone. That's what we wanted. Negative 9y plus 8y is negative y, or negative 1y, equals 15. Divide both sides by negative 1. Y equals negative 15. Now that you have y, we just need to find x. Take one of your original equations. We now know that y is equal to negative 15, so sub that in. Negative 3 times negative 15 will be positive 45. Now solve for x. That's a 45. So 1 minus 45 is negative 44. Divide both sides by 2. X equals negative 22. So our x-coordinate is negative 22. Our y-coordinate is negative 15. These are a little larger numbers than we're used to. I'd make sure to plug them back into my original equation and check. Okay, what should we eliminate? I think I'll choose the x's, although it's okay to choose the y's. And I noticed that if I times 3 by 3, I'll get 9. So if I just multiply this equation by a negative 3, I'll turn this into a positive 9x. Notice why I have to do the negative. Both of these are negative right now. I need them to be opposite signs. So if I do a negative times a negative, that'll turn this first one into a positive. And 3 times 3 will make 9. So I'll have positive 9x minus 21y. Negative 3 times negative 16 is a positive 48. And then this equation I can just leave the same. There are other ways to do this. You could multiply both top and bottom equation, let's see, the top one by a negative 5 and the bottom by a positive 7. That would get rid of your y's. So there are other correct ways to do this. Now I can add my equations together. My 9x's will eliminate, add up to be 0. Negative 21y plus 5y will be negative 16y equals 64. Get y by itself, divide off the negative 16. So y is equal to negative 4. Now that I know y, I need to find the x. So take one of your original equations. I know that y is equal to negative 4, so sub that in. Solve for x. So my answer, the x-coordinate is negative 4. The y-coordinate is negative 4. Negative 4 is my answer. Notice something a little bit different about our last problem. All of our other problems were in standard form, and this one's not. So what we need to do is line up. You have to have the x's line up, the y's line up, the equals line up, and the constant terms line up. We don't have that. We can mess with this algebraically, though, to make sure that we do. If we just algebraically move this x to the other side, we'll have negative x plus 3y on the left side equals 10 on the right side. And then we'll line up. So I'm just going to rewrite my equation so that they line up. And now I've changed this one to negative x plus 3y equals 10. Okay, now we can get on with business. All right, let's see. I'm going to work with the x's, I think. I already have opposite signs, so if I just multiply my second equation by 4, I'll have 4x on top and negative 4x on the bottom. So that's what I'm going to do. Again, I'm multiplying by a positive 4 because I already have opposite signs. So my top equation I'll leave the same. My bottom equation there. Now in the x's I have the same coefficient, opposite signs, so I can now add my equations together. Use the addition method. 4x plus negative 4x is 0. That's gone. That eliminated. 5y plus 12y, 17y, equals 11 plus 40, 54. No, 51. Now I can solve for y. So I've got y equals 3. I just need x. So take one of your original equations. We now know that y is 3. So sub that in. Five times 3 is 15. I can solve for x. So my answer, the x-coordinate is -1, the y-coordinate is 3.